let's shift gears a little away from probability and into counting. So now 4.8 gives us different strategies for counting depending on the situations. The first strategy that we learn is the multiplication principle, which means if we have different ways of doing one event and different ways of doing a second event and different ways of doing a third event, in order to find the total number of ways to do all three of the events, we're going to multiply them together. So here, if a woman has 2 blouses and 3 skirts, how many different outfits consisting of a blouse and a skirt can she wear? We could turn this into a tree diagram, for example. We could start out blouse 1 and blouse 2. And then she has 3 skirts, skirt 1, skirt 2, skirt 3, skirt 1, skirt 2, skirt 3. So her outfits consist of blouse 1 with skirt 1, blouse 1 with skirt 2, blouse 1 with skirt 3, or blouse 2 with skirt 1, blouse 2 with skirt 2, and blouse 3 with skirt 3. Granted, this isn't very practical because likely her different skirts might not match both blouses, but let's say that she's one of those savvy dressers that is able to mix and match her clothes in such a way. She has 6 different outfits that are completely different. How do we come up with this number? Well, without drawing a tree diagram. Well, we can say how many blouses times how many skirts. She had 2 blouses and 3 skirts, and that gives us 6 total outfits using that multiplication principle. Let's take a look at another example of counting. A truck license plate consists of a letter followed by 4 digits. How many such license plates are possible? So we have a letter followed by 4 digits, 4 numbers. Number, 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 number. In the English alphabet, we have 26 letters. Since there's nothing in the problem that says we cannot use, for example, O or I or Q, some places don't allow us to use those for license plates. This problem does not state, so we're going to assume we can use all of those letters. And then digits. How many digits can we have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Don't forget 0, my hero. We have 10 different digits. And since we can have a number repeated, so we could have a 1111 as a license plate, that's valid, then we could have we have 10 different choices for each one of those digits. Multiplying these together, we end up with 260,000 different license plates with this situation. And this is just using that multiplication principle again, because we have one letter followed by 4 numbers and 10 digits for each number. In our next example, in how many different ways can a 3-question true-false test be answered? Well, since we have 3 questions, I'm going to create 3 spaces, 1 for each question. We know the question is true, false, true or false. So how many options do we have to answer question 1? True or false, there are 2. Similarly for question 2, and similarly for question 3. True, false, we have 2 choices for each question. And if we multiply those together, we have 8 different ways a 3-question true-false test can be answered. If we wanted to write them out, this actually isn't too bad. It just takes some time. We could answer all 3 of them true, We could answer the first two true and the second one false, the middle one false, or the first one false. We could answer two of them false. But there are different ways we can answer two of them false. And then the last option is if all three of them are false. And notice there are 8 different options.